So good morning, everybody, and thanks for being with us today. My name is Elisa Marino, and I'm the Store4HUC project manager for the city of Cuneo, which is one of the 10 project partners of Store4HUC. Today I will talk about the pilot action in Cuneo that concerns the energy efficiency action on the sloping elevator through the installation of a PV plant and a storage system. But let me first talk about the context a bit, because I think it's important for you to understand why the elevator has been chosen as the pilot action of the project. Some of you may know that Cuneo is a medium city located in northwestern Italy, in a very suggestive area, I think, because it is surrounded by the mountains, by the Alps on two sides, and by the Langhe and Roero hills on the eastern side. It is called the green capital of the whole Piedmont region, of course, because of its location in a very natural territory, but also because of its attention to sustainability. So the city of Cuneo is making a lot of efforts to get more sustainable from many points of view. And one of that is also the sustainability of mobility systems. And the pilot intervention of Store4HUC really try to achieve this objective. Of course, we also have many outdoor activities going on, and I think that it's more important that we talk about the name of Cuneo in order to understand why the sloping elevator has been chosen for the pilot action in Italy. Cuneo in Italian is a word that means wedge, because of its very peculiar shape. So as you can see from the picture, the city has this sort of shape that is made by the two rivers that run along the city, which are the River Gesso and the River Stura. And they really dig up two valleys in ancient times, and currently the city is located on a plateau. So this means that actually the city center is a bit higher from the rest of the surroundings and from the suburbs also of the city that are located here. In this case, for example, where the sloping elevator is located, there is a difference in height of around 30 meters. So how did the city of Cuneo solve the difference? Because it is really important for citizens to be able to overcome this difference in height in order to reach the city center, in case they don't want to use the car parks located on the plateau. In 2009, this sloping elevator has been constructed and opened, and it consists of a cabin that has a capacity of up to 26 people. Of course, this capacity was before the COVID-19 situation. Currently, it can host only 4 people at a time. But also bicycles and wheelchairs are allowed, and this makes the cabin highly used by the whole citizens. It can make a maximum of 48 rides per hour, so it's quite slow, but it can really bring to zero the difference in height from the suburbs and the valleys of the River Gesso to the city center. It is a very highly used facility because it connects the city center to this area here that you can see in this picture. Where a free car park, a very big one, is located. A newly swimming stadium is also located. And here we also have an environmental education center for the natural park of the River Gesso and Stura, also the psychonaturalistic itineraries of the park, and a newly opened multisensorial park called the Forma. So people really use this area a lot, and they want to be connected to the city center where all the commercial activities are located. So you can understand that actually the usage of the elevator is quite high. Here I have not too updated information, but in general, we can say that the elevator makes about 700,000 rides. It can host 700,000 passengers per year, and per day it can make about 400 rides in total. During the COVID situation, these numbers did not change much because, of course, the cabin capacity was highly reduced. So there was always quite a long line of people waiting for their turn to go on the elevator. So this is one of the reasons why the city of Cuneo decided to to make the pilot intervention on this sort of facility. The pilot intervention consists on the energy efficiency intervention, and it's made of a PV plant installation along the runway of the elevator, of a storage system made of a storage unit plus an inverter, of a technical room for hosting all the electric equipment, and then the laying down of the underground cable ducts. In total, the intervention will cost 95,000 euros that will be financed by the project itself, but that will, of course, bring many benefits from the economical and from the carbon emissions points of view. So here you can see the project design. Here on the lower side of the sloping elevator ride, there will be the installation of the PV plant made of 26 PV modules. On the top station, it's being constructed the technical room that will be located on the side of the already existing station, uphill station, so to say. And here you can also see how the PV modules will be installed with an inclination of about 20 degrees. Of course, we needed a landscape authorizations because the elevator is located within the natural park area, but then we obtained that, and that was the only restriction that we had. So we're happy to have obtained it because then we could have moved on with the intervention. But let's talk about the energy consumption and how the pilot intervention could help to lower down the energy demand coming from the power grid. A detailed monitoring of daily consumption has been made in 2020. As you can see from these graphs, the highest energy consumption occurs in weekdays because the elevator is highly used by workers that reach the city center from the car park. The elevator is also open on weekends, but of course the usage is less intensive because it is mainly used by citizens that go to the natural park and to the swimming stadium. Of course, the highest energy consumption occurs from 7:30 a.m. to 20 p.m. because that's the opening time of the elevator. Thanks to this detailed monitoring analysis, it has been possible to have an annual projection of consumption. And that one was associated with an estimation of the annual PV production for a plant of nominal power of 10 kilowatts. As you can see from this graph, it's been estimated that the 60% on an annual average of the energy consumption will be covered by the eventual auto production from the PV plant, while the 40% cannot be covered by the PV production, of course, because it will occur at night times or when the PV plant will not produce energy itself. But from the detailed monitoring, it's been possible to estimate the nominal power of the PV plant to be installed, which will be of 8.84 kilowatt peak. What is interesting of the elevator, in our opinion, is that actually there are three different sources of energy supply. One is the elevator itself, because of the difference in weight between the cabin and the counterweight. So going uphill, if the cabin is empty, it actually produces some energy because the counterweight is louder than the cabin itself, while going downhill and being fully full of people, of course, it will also produce energy because it weighs more than the counterweight itself. So some of the production, not a big amount, but anyway, some of the production is produced and now it is dissipated as heat. Of course, another source of energy will be the PV plant. For the intervention, it has been estimated that we will need 26 PV modules in monocrystalline silicon, each with a nominal power of 340 watts. So originally there were more modules, but then they have been reduced because of the nominal power that was increased thanks to the technology moving on, so to say. The third source of energy is, of course, the power grid. We cannot be fully independent from that because, of course, as you can see from the graph, there will be some periods in which the PV plant will not be able to supply the sloping elevator with the energy needed. Of course, we will need to take it from the power grid, but of course at a lower cost, because we will be able to reintroduce the extra energy auto-produced in summer and spring months by the PV plant into the power grid, and then get it later at a lower cost, thanks to the net monitoring system. So this is what I've already said about the allocation of the auto-produced energy. What makes all this intervention possible is, of course, the storage system, which is made of the storage battery and of the inverter. The inverter will allow for 4 different fluxes of energy. The first one going from the PV plant to the elevator itself directly when it is needed. The second flux will allow the energy auto-produced by the PV plant to be stored in the battery when it is not directly needed. Another flux will allow the energy to stored in the battery to be reinserted in the sloping elevator for its functioning at night times, for example, or in winter days. And the fourth flux will allow the energy auto-produced by the elevator itself to be stored in the battery. So this is really a super efficient system that allows for the best saving of energy. The battery itself will consist of 7 modules of lithium iron phosphate kind. The total capacity of the battery will be 19.32 kilowatts hour. So what are the benefits of this storage? Of course, it will allow to store at the maximum the extra energy auto-produced during non-functioning periods. And consequently, this would limit the absorption peaks and would also sustain the energy consumption during night times, because of course, some energy will be needed also for lights, for video surveillance, and so on. The energy storage will allow also to exploit the net metering opportunity by reinserting the extra auto-produced energy and by reusing it at a discounted price later. And the storage also allows to store, of course, the auto-produced energy coming from the elevator and balance rights, as I said before. It is estimated to save about 3,500 euros per year, so it will not be a very high money saving, but anyway, it will be, I think, interesting for the municipality to show that this kind of intervention actually can allow for some energy savings, money savings, and CO2 emissions reductions. Works for the intervention have started in May 2021 and they're not completed yet. I would like, if I have time, to show you a short video of the works going on so that you can get an idea of the sloping elevator. And then I will end up with the last slides. Go back to the slides. So as you could see from the video, the construction works are almost completed. Currently, the electric components are arriving, so the battery systems and also the PD modules, and they will be installed in the next couple of weeks. Of course, then we will need the authorization to use the PD plant from the national authority. That might take a bit of time, but we'll try to do our best to finish by the summer. What is interesting of the intervention is that we will be able also to test the energy monitoring system tool, the module 1 specifically, that has been developed by the technical partner of the Store4HUC project, to see if the choice of the PV system and of the storage components was adequate for the energy efficiency required. So let's hope that this intervention will end up soon, and that we will be able to provide you with more videos and more information on that, to see if it actually helps the objective of the city of Cuneo to be more sustainable as possible. This is all from my side. If you have any questions, feel free to ask. Also by email, you can see our addresses here. Thank you, and enjoy the rest of the meeting.